Welcome in, welcome in. Happy Monday, everyone. We are going to be doing some algebra tonight. So if you know anybody that's struggling with graphing, that's what we're doing tonight. We're graphing linear lines. Thank you for the double taps. Welcome in. Happy Monday. So we're going to start with graphing, and then we're going to write equations, do some graphing. I hope everybody had a wonderful weekend. Thank you for the double taps. And let's get started. So number 1 says y equals 2x minus 1. When you're graphing linear lines, you have to be able to identify the m and the b. Remember, the b is the y-intercept and the m is the slope. Okay. So can I see anybody know in the chat, what is our b for question number 1? What is the y-intercept for question number 1? Welcome in. Emily said -1. Beautiful, Emily. Happy Monday. Beyonce said 1. Good. Don't forget the sign on that. Beautiful. So -1. Remember, -1 is on the y-axis. This is our y. So we're going to put our first point at -1. Now, does anybody know our slope? What's our slope? Oh, good, Gina. Oh, well, I'm glad you're here. Grab you a piece of paper and join us. 2 over 1. 2 over 1. Good. Yes. 2 over 1. Remember, every whole number can be written over 1. And this is rise over run. Okay. So we're going to rise up 2 from our starting point. And then we're going to run 1 to the right. So we go up 1, 2, and then over 1. We put a point. Now, really, technically, you only need 2 lines to graph a point, right? But we're going to just do a couple of more. So this is 1, 2 over 2. Over 1. So don't ever count this, because some of my students were like 1, 2. They were counting like 1, 2. No. You go 1, 2. So you count the hops, okay? Just for anybody that does that. 1, 2, and then over 1, okay? Now, we can also go the opposite direction, right? We can flip these to their opposite. So we can go down and to the left. So we can go 1, 2 over 1. 1, 2 over 1. Okay. So this is our first line. Okay. Beautiful, beautiful. So that's line number 1. We did that in blue. Now let's go to the second one. All right. Can everybody put their M's and their B's in for number 2? What is the M and what is the B? Let me see it in the chat. Does anybody know for number 2, what's the M and what's the B? Welcome in, everyone. Happy Monday. Thank you for the double taps. One. Okay. Hey, Terry. I hope you had a good Monday at school. Welcome back. Okay, so I see M is negative. So the B is always the number that doesn't have a variable attached, okay? That's called the y-intercept. So it'd be -3. So B is -3. And remember, again, this is the y-intercept. So we start at -3 on our y-axis. Then our slope says it's 3 over 1. Because every whole number can be written over 1. And what slope is, let's talk about what slope is. It's rise over run. Remember, when you're rising, you go up or down. And when you're running, you go left or right. So here, we're going to go, since it's a +3, we're going to go up. And since it's a +1, we're going to go right. So from here, we're going to go 1, 2, 3 over 1. Put a point. Let's do a couple more. 1, 2, 3 over 1. 1, 2, 3 over 1. Okay, so we have our top half, which is right here. Let's go down. Let's find our bottom half. So we would do the opposite. Remember, if we go down, then we have to do the opposite and go to the left. So we go 1, 2, 3 and over 1. 1, 2, 3 and over 1. And that gets us our bottom. All right, now for all my Algebra 1 students that have done systems, does anybody know the solution? If these were two systems, can anybody identify the solution? Doing great, getting ready for a trip to Vegas for break. Oh, have a wonderful time. I hope you win super big. If you gamble at the casino, win big. I'm wishing you all the luck. Hi, yes. Liz said 2, 3. Kaylin said 2, 3. The intersection point. Wonderful, you guys. Yes. And so our intersection point, if we were looking for the intersection, would be 2, 3. Wonderful at identifying that. We always go X, then Y. So that's why it's 2, then 3. Good. Yeah, you said me too. Wonderful. All right, so let's do number 3, you guys. Number 3 is going to be y equals negative 2x plus 2. We're going to always identify our m and our b. So our b is 2, positive 2. Now I have a question for you guys. Am I going to start here or am I going to start here? So am I starting here? Say yes or no. Let me see it in the chat. Yes or no. Koya, linear inequalities. Man, something was telling me to put that on here too. Graphing, right? No. Good. I'm glad I see the no's coming in. This is not the y-axis. This is the x-axis. Oh, let me put it over here so you guys can see it. This is the x. Remember the y, the b stands for the y-intercept. So you have to go on your y and you have to find 2 on the y. And you put a point there. Okay? So that was trying to trick you. Yes, I did trick some of you guys, but that's okay. So hopefully I trick you now so you don't trick on your test. It starts here, okay? Big Key said, currently studying for my GED. You have been so helpful. Oh, thank you, Don. And I can't wait for you to come back and tell me that you have beast moded that test, passed it with flying colors, and you on to the next, okay? Gina said, I'm confused about rise over run. How is it calculated? Good. Okay, Gina. It's calculated. Okay, so this is the slope, okay? Your slope is always next to the letter X. It's always attached to it. Now, what might be confusing is where does this 1 come from? You have to understand that every whole number, integer, every whole number can be written over 1. So when they say slope is rise over run, and you just see a negative 2, you have to know that that's really over 1. So that's how you get the run. Okay. So here, since it's a negative 2, I'm going to be falling down 2. But here it's a positive 1. So I have to go to the positive right. Okay. Good. Koya said, if there's 2 points, Koya's giving us the formula. I don't teach this, so you're working my brain. Oh, I love it. Koya gave us the formula for slope. Also, if you're given 2 points, it's y2 minus y1 over, my green is going out. Hold on, let me switch it. Over x2 minus x1, okay? And if you put 1, 1, 2, 2, that's the same thing, okay? So this is our formula here if you're given points. Now that we know so we started at 2. Now we're going to drop from our starting point. We drop 2, 1, 2. And then I run 1 to the positive. Drop 2, 1, 2, over to the positive. 1, 2, over to the positive. Okay. Now my question is, if I need some points on this side, I'm going to go up. But do I go up and right, or do I go up and left? Which way do I go? Up and right or up and left? Let me see it in the chat. Jackie said left. Good, Jackie. Yeah, I do have quadratics. We're going to write some equations for some linears. And then we're going to jump into some quadratic equations, as long as the baby don't wake up. So we're going to write some equations for quadratic. We're going to get into vocabulary for quadratics. So that is what's coming up. Okay. So again, if you draw your arrows, I always focused on my students doing this. If you draw your arrows, you can go to the opposite. So you will go up and then left. So you will go 1, 2, and then 1 to the left. 1, 2, 1 to the left. And that right there would be your line. Okay. So remember, you have to go opposite direction for both. Okay. All right, let's do number 4. Okay, so we're going to switch color. So we're going to go to pink. So we have our M and we have our B. Our B is -3. Okay, remember, it's the number that doesn't have the X attached to it. So we're going to start at -3 here. Then our slope tells us, let me see what the slope is. Tell us what the slopes is. How are we going to write it? Let me see it in the chat. Welcome in, everyone. Can everybody double tap their screen? Can we get to 5K likes? I'm going to double tap with you guys. Thank you for the follow, BJ. Thank you, Pretty, for the follow. Jackie said -6/1. Nina said -6/1. Let's go, you guys. Yes. -6/1, right? This negative tells me I'm going down from my starting point. And then this +1 tells me I'm going to the right. So I'm going to go down 1, 2, 3, 4, 5, 6. And I'm going to go over 1 to the positive. Okay. Now, if I switch this direction, I'm going to go up, and then I'm going to have to go left. So I'm going to count 1, 2, 3, 4, 5, 6, and over 1. And then this right here is where they intersect. Or that's the pink line, right? Any questions on this one for number 4? Oh, thank you, Amy. I would love it. That would be so helpful. Thank you, Nurse Max, for the follow. My teacher made me make a table, which was way more annoying than doing rise over run. Yeah, I know. I do have some tables coming up, because when you start to get into transformations, you know, it does help a little bit with just understanding what's happening. It is annoying, though, if you know this right away off, right? All right, let's do... What color am I going to next? Okay, let's do 1/2 x plus 2. So our B is 2. Okay, it's the number that doesn't have the x. So 2, we're starting here. Okay, my slope tells me 1/2. Okay, I have a +1. That means I'm going up because it's rising. And I'm going to the +2 here. So from this point 2, I'm going to count 1 up over 2. Boom. 1 up over 2. 1 up over 2. All right. So I have a question now. Is my next point going to be... Okay, this is my question. Is my next point going to be 2, -2? or negative 2, 2. Which one is my correct next point? Yes. Yes, Terry. So Terry said, so whatever your B is, that is the point you begin. Yes, B is always our starting point. Okay, I see 2, negative 2. I see negative 2, 2. Oh, we got 50% right now. Okay. Neither? All right. So remember we started here, right? Our slope was said we go up 1 over 2. But if we need the other way, we're going to go down 1 and to the left 2. So we're going to go down 1 over 2 this way. Ooh, it was neither. It was neither. I went too high. So it's actually negative 2, positive 1. That actually was the point right there. If we go down 1 over 2. I love that. Whoever said neither. Hobbs, love it. Jackie, yeah, good. Jackie said it, negative 2, 1. I love it, you guys. Good. Down 1 over 2. So it would be here. All right, let's talk about a little bit of vocab before we do our last one. Okay. Because this is going to be really crucial when you get into quadratics, right? So let's identify the x-intercepts. Okay. And let's only identify the green and this color. This whatever color this is. It's losing my mind right now. I can't even tell you what color this is. So let's do the green x-intercept and the is this maroon? I want to say maroon because it ain't red, but it's like maroon. Oh, we should do domain and range. Yeah, we should talk about that. Thank you. Koya, you coming through with the vocab. Let's do it. So everybody, let's identify the x-intercept for the green line. What is the x-intercept for the green line? Thank you, Anna. Maroon, yeah, maroon. You go back to sleep. Does anybody know the x-intercept for the green line? Oh, somebody said plug in 0 for x. So thank you so much, Mokas, for the roses. Thank you, thank you. Anna said 1, 0. Good. Okay. Remember, the x-intercept has to be where it has to cross the x-axis. So the x-intercept is actually right here for the green line. It would be 1, 0. This point right here is on the x-axis. So that's the x-intercept. Thank you so much, Mokas, for the hearts. I appreciate it. Thank you, thank you. Yes, Amy said, I said that. Beautiful. You understand it. Perfect. So we never have to, another way you could have done it, yeah, you could have plugged in, oh, you didn't want to plug in 0 for x because that would have been solving the y-intercept. You wanted to plug in 0 for y. And then that would give you the x-intercept, okay? But that's the long way, especially when you could just look on the graph. Okay, so let's find the x-intercept for our maroon. So where's the x-intercept for our maroon? Hey, Tyler. Nina said negative 4, 0. Anna said negative 4, 0. Perfect. Negative 4, 0. Right here on the x-intercept. On the x-axis. Perfect, perfect. Hi. Do you want to say hi to the people? Good. All right. Let's do this last one. Let's see. What color didn't I use? Let's do red. Okay. So our M and our B. Thank you, Pillows, for the rose. You're so welcome, Pillow. So B is our 1. Okay. So we're going to put It's starting to get a little crowded, but that's why I did all the colors, you guys. So I did 1 on the y-intercept. Our slope is going to be 2 over 3. We're going to go up 2 and to the right 3. Hi. Okay. Then I'm so confused. Kimberly, it's probably because we're like, if you started with us at number 1, you probably, hopefully it'll get better when we start talking about writing. Okay. So what we're doing right now is we're graphing number 6, and we just identified our slope and our B. The B is your starting point on the y-axis, okay? So on this y-axis, we put a point at 1. Then from this point at 1, our slope says to rise 2. So we go 1, 2, and we run 3 to the right. 1, 2, 3, and we put a point. We're going to do that again. Rise 2, 1, 2, and we're going to run 3. 1, 2, 3, and we put a point. Okay, so right now our line is going like this. Okay, now I need to find some other points over here. So we're going to go the opposite. We're going to go down and then to the left. So we're going to go count down 2, 1, 2, and we're going to run 3, 1, 2, 3. Boom. Okay. And then we could do it again. 1, 2, 1, 2, 3, and put a point. And this right here is how we graph. Now let's talk about domain and range. Okay, because those are some more important words, right? So domain, you're dealing with the x-axis. Okay, it's always for the x's. And since this is a line, it goes on and on to all the way to negative infinity. And it's going to go on and on to all the way to positive infinity. So you could write negative infinity to positive infinity if you're writing in interval notation. Or you could say all real numbers. That's another way. What about end behavior? So we would have to do it depending on which line. So like for the red line, right? If we talk about end behavior, this would be like a increasing line because we read from left to right. So we're starting down and it's increasing. I think you really talk about end behavior more with quadratics, U shapes, or double lines and an R shape. An R shape. What's an R shape? Do you mean a U shape with parabolas? Koya? So this is for all real numbers. A R shape? Oh yeah, like this. All real numbers. Like, is that what you mean? Do you get into slopes of quadratics? Not so much with the slopes of quadratics. We're just going to be graphing quadratics. And then we'll jump into writing the equation for quadratics. And then we'll talk about, we'll probably do this first before graphing them. We'll talk about like the vertex, axisymmetry, concavity, all that, okay? That's what I have for us, if little man lets me get that far, okay? But let's finish up with range. So the range. Come on. You want to sit with mama? So the range is where we talk about the y-axis, okay? And the y-axis, whenever you have a linear, it's going to go all the way up to positive infinity, and it's going to go all the way down to negative infinity. So again, it's all real numbers. okay? For domain and range, for linear, okay? For linear. Now, I have a question. Do I have a lot of people in linear or do I have a lot of people in quadratics right now? Do we want to skip to quadratics? Because I don't know how much time I have. Do we want to just get to some quadratics? Oh, exponential. Yes, yes, yes. The curve. Okay, yes. Yes, Big Key says yes. Yeah, that should be good. Okay. All right. Okay, so let's do some quadratics, okay? Because I don't know how long this baby boy gonna let me stay on. So let's do some quadratics. Let's go over the vocab, identifying the key features first, and then we'll go back to graphing it, okay? Okay. Okay. So, identify the key features. Okay, so first off, this is a parabola, okay? A U shape is always called a parabola, which means it's a quadratic, which means it's going to be y equals x squared. That's the base formula, okay? Y equals x squared. All right, the vertex, okay, let's talk about what the vertex is. The vertex is always your lowest or highest point. It's always the lowest or highest, okay? Which you might heard your teacher say maximum or minimum, right? So here, this would be called the vertex. The vertex. Our vertex in this case is going to be -1, -1. This point right here is our vertex. Okay. Does anybody know, good Riley, does anybody know the axis of symmetry? Does anybody know what the axis of symmetry is? Thank you for the share. We're at 4.2K likes. Can everybody double tap their screen for me? Can we get to 5K? I forgot that one. Okay, good. Somebody said -1. Good. What the axis of symmetry does is it cuts your parabola in half. So the axis of symmetry is going to be this dotted line right here. And how you can remember what the axis of symmetry is it always has to be the x value of your vertex. So x equals -1. It's always the x value of your vertex. That's what the axis of symmetry is, because it has to fold. It folds this parabola in half going through the x-axis. Any questions on that part? Yes, it's always symmetrical. Beautiful. Good. The part that splits the parabola in half. Beautiful, you guys. Okay, somebody said all righty. All right, so now let's talk about our y-intercept. What is our y-intercept for this parabola? Thank you, thank you. I do see those double likes coming in. Thank you, user, for double tapping. Thank you, Chrissy. I appreciate it. Good, we're at 5.4K. Thank you. 0. I see 0, 0. Good. Okay, so the y-intercept, which is right here on the y-axis, would be 0, 0. This point right here is the y-intercept. Perfect. Now, what are the x-intercepts? What are the x-intercepts? Wow, wish you were a teacher or my teacher in school. You make it super easy to get. Oh, thank you. Okay, so -2, 0. Ooh, -2, 0. Okay. Thank you, Keisha, for sharing the live, hun. Thank you. Good, Leisha. Yes, Leisha, let's go. Said -2, 0, and 0, 0. Yes. Let's talk about it. Remember, we're looking for points on the x-axis, right? So this point is on the x-intercept, is on the x-axis as well, and here is the x-intercept. So we actually have two. And these can also, later you guys will find out, these are called roots. When you're solving quadratics, you'll hear that term called roots. And basically they mean the same thing, x-intercepts. Okay, it's another word for x-intercepts. So 0, 0. Perfect. Good. All right, when we talk about concavity, we're asking, does it open up or open down? So is it up or down? Up, up, up. Good. Yes, it is going up. I should have put arrows on here, but yes, it is up. Okay, so it concaves up. All right, perfect, perfect. Okay, good. So we identified all our parts, our key features. Okay, we didn't do end behavior. I don't know too many people. I don't know too many teachers do that. If they do it, but I don't want to teach it because I have to refresh myself. I always forget in behavior. So I don't want to throw anybody off. I would have to look it up, remind myself. Yeah. Yep. All right. So let's go to the next one, you guys. Let's go to the next. Okay. Can everybody put the vertex? What's the vertex of this parabola? Can you put it in the chat? What does AOS mean? AOS means axis of symmetry. That's what it means, axis of symmetry. Yep, you're so welcome. Mel said -1, 0. Good, Mel. Riley, yes, you guys. Beautiful. Yes. So this right here is our vertex. It's the highest or lowest point. And so that would give us -1, 0. Perfect. Now, what is our AOS? What is our axis of symmetry? Does anybody know? -1, -1, -1. Perfect. But remember, you guys, an axis of symmetry is always an equation. It's a vertical line. So, some teachers take off for this. So you have to make sure you put x equals -1. And then I always would have my students draw in the axis of symmetry. I guess I should have put that as AOS. AOS here. X equals -1. X equals -1. Okay. Now, what's our y-intercept? Let me see it in the chat. What's our y-intercept? And remember, I said the axis of symmetry always has to be the x value of your vertex. So that's another way to remember it. Ooh, I see a -1, 0, 0, -1. Ooh. And this is common. Common, you guys. Okay, so this right here is the y-intercept, right? Because it has to lie on the y-axis. So if that's the y-intercept, remember, this is 0, -1 for the y-intercept. Because the number, remember, whenever you're graphing a point, you write it as x, then y. So since this is -1, the -1 has to go in the y position. And here, the x value is 0. That's why it's 0, -1. I hope that makes sense. Okay. Why it's 0, -1. Okay. All right. Our x-intercept. X-intercept. Yes, it does. Good, the unknown. Perfect. Good. Floor said -1, 0. Good. Because this is also, since it lies on the x-intercept, it is also our x-intercept. Vertex and x-intercept are the same. Oh, no, Tony. I'm so sorry. I hope I'm not giving you stress right now, okay? So does this concave, what's our concavity? What is it, up or down? Is it up or down? Thank you for the double taps, you guys. Thank you, thank you. Concavity, since it is pointing down, since the arrows are going down, we would say down, okay? PSN, this is perfect. Wish you were around when I needed this. Oh, thank you, Matt. Main Hunter. Thank you. I know I'll be slacking. I need to start going live every day. Hey. Where you trying to go? All right, perfect. Any questions on this? Anybody got any last questions before we move on? All right. Good. I'm glad you was right. Good. Okay, everybody's good. All right, so we did one of identifying the features. Let's do our graphing, okay? Let's go to graphing. Okay, so number 1, it says y equals x squared plus 4. All right. I'm going to do a table. Just in case anybody gets a little bit lost. We can always undo the confusion when we do a table, okay? So, let's say if I put in 0, -1, and 1. So what am I plugging in for x first? I'm going to plug in x for -1. So I'm going to say -1 squared plus 4. What's that mean? All right, so -1 times -1 is 1 plus 4. Well, 1 plus 4 is 5. Okay. If we plug in 0 here, let me do it. I'm going to do it over here. 0 squared plus 4. 0 times 0 is 0. And then plus 4, we get 4. Now, let me tell you something, you guys. How you know this is a parabola is after your vertex point, this and this number always has to be the same. Yeah, what you telling them? You trying to teach them math too? You guys, he's been making all kind of noises, talking. I'm like, you out teaching me, okay? Somebody said because of the parentheses. Oh, why? Oh, let me see a question. Question was up there. So somebody said, let me see. What was the question? Okay. Why would it be -1 and not 1? It's gonna be why is it not -1? Because this squared is, what this means is you're doing -1 times -1. And a negative times a negative is always a positive. And 1 times 1 gives us 1. That's why it does not become -1. It becomes a positive 1. I hope that was a great question, okay? And if we plug in 1 from this x here, if we do 1 squared plus 4, we'll get 1 times 1 plus 4. Well, 1 times 1 is 1, plus 4 gives us 5. You'll see this pattern every single time. Whatever number you have here must be here after the vertex. If it doesn't, that you did something wrong. Okay, that's to tell you that you did something wrong. So now we can graph. So we can graph our first point. I always graph my vertex first. 0 up 4. Okay. Then we have -1 up 5. And 1 up 5. And this right here is our parabola. Now you could go further and figure out some more points, but technically you only need 3 points in order to graph a parabola. Any questions on that? You only need to do 3 points for the table. Yeah, you really only need 3 points to graph a parabola, but you can do 5. Most teachers make you guys do 5. Up. Good. Yes, it is up. Okay, now let's talk about it. Our parent graph. I should have had everybody do the parent graph. We're going to do the parent graph. Y equals x squared, okay? Our parent graph is always 0, 0, 1, 1, 1, 1, okay? This is our parent graph, okay? That's the parent graph. So let's talk about, because this is a transformation, right? So what this +4 did to our parent graph is it moved the original graph up 4 spaces. So if you understand that this +4 is just moving the original up 4, then you don't have to do the table. You just say, okay, this is my original. I go up 4 spaces. Every point moves up 4. Well, let's talk about if we have this next one. Okay, let's talk about the next one. If we have -4 here, that means from this point, I'm going to go down -4 spaces. So I would be putting 0, -4. And then what this -x tells me is it flips. It's a flip. So instead of going up right here, I would be going down here and here, because it flips it whenever you have a negative attached to the x squared, it makes it go down. Oh, thank you, Bryant. Oh, thank you, thank you. So this -4 tells me I'm moving from my original graph down 4. I'm doing a vertical shift down 4. This right here, negative in front, tells me it's a reflection over the x-axis. So instead of going up, I have to flip it down. Any questions on this one? Thank you, Nima, for the rose. Thank you, thank you. Thank you, Hobbs, for the follow. Thank you, Nima. Okay, no questions? Okay, let's do number 3 then. Let's go to number 3. So for number 3, does anybody know about vertex form? So in number 3 is in vertex form. Okay, and vertex form says, let me give you the parent fraction, y equals a times x minus h squared plus k. This is vertex form, okay? Your h and k is always called the vertex. Can anybody identify what the vertex is for number 3? Ooh, we have, okay, Koya, I see you. Koya said the vertex for this is -6, -3. Beautiful. This is what my students trip up. They want to put a +6 here. You cannot put a +6 here because the formula is -h. So if you get a positive, really you're multiplying that by a -6. Just remember, this is always opposite. H is always opposite of what you see. So if you see a positive 6, you're going to put a negative 6. If you see a negative 2, you have to switch it. So this is, H is always opposite. K is always as is. So beautiful. So let's graph this one. Negative 6. And so we're going to go negative 6, negative 3, which I believe should be right here. And then since we have no negative in front of here, we're going to go over 1, up 1, over 1, up 1, and we're going to graph our parabola. And that's our parabola. All right, so let's do number 4. What is the vertex for number 4? Let me see it in the chat. Couldn't you use the vertical stretch of the leading coefficient to tell another point? The vertical stretch of the leading coefficient. Yes, and since this is a 1 right here, since it's just a 1, that's how come we know it's going over, up 1, over, up 1. If it was a different number here, then we would have to calculate that in. Okay. 2, 4. Good, you guys. Yes. The vertex for this one is positive 2, because we do the opposite of the H, and the K is as is. As is. Okay. So we have 2, 4. So we go 2 up 4, which is right here. Now we have a negative. So are we going up or down? Let me see it in the chat. Up or down? What does that negative tell us to do? Up or down? Are we going up or down? Oh, I think my phone froze. Okay. Nina said up. Up. Okay. We got an up. So whenever you have a negative in front, remember that flips it down. So it would actually have us go over 1, down 1, over 1, down 1. Whenever you have a negative in front of the X, it flips it down. So I'm glad you said that, found out here, so you don't make that mistake on your test, okay? So whenever you have this negative, it flips it down, okay? All right. So we did standard form, vertex form. Now we're going to go back to standard form, okay? I'm going to show you how you can find your vertex with the vertex formula, okay? The vertex formula that you would use to find your x would be x equals negative b over 2a. And in order to use this, you have to know what the a, b, and c is of the trinomial. Does anybody know what the a is? Can you guys put it in the chat? What is the a for number 5? Negative 1, 4. Okay, I see negative x squared. Good. Okay, so let's talk about it. Y equals the base, the standard form is ax squared plus bx plus c. Okay, so the a value is always attached to the x squared. Well, we have a negative x squared, so the a value is going to be negative 1. Our b value is always next to the x. So the b is going to be negative 4. And our c is the number, is the constant, okay? The c is the number that doesn't have any variable attached to it, any letter attached to it. So it's going to be negative 10. So now that we know our a, b, and c, we can plug into our equation. So a lot of students forget this part. They forget a negative, and then you have to put parentheses because it's a negative times b. So that's why we put negative, then parentheses. And we're going to plug in what the b is. Well, my b is -4. So that's why I'm putting -4 in the parentheses. Okay. Over 2 times my a is -1. All right. Let's simplify this. What's our answer? What do we get for x? What do we get for x? Thank you for sharing the live. Ooh, -2, 2. Ooh, is it a positive? Is it a negative? Let's talk about it. Let's talk about it. A negative times a negative is always a positive. So we have a +4 here. 2 times -1 will give us -2. 4 divided by -2 gets us -2. So our vertex for this, our x-axis will be -2. Okay. Now that we have -2 here, how do we get the y? Well, we would plug this -2 in for x. So we're going to literally put in this -2 here into this and substitute in for x's. So we're going to do that over here, you guys. Okay. So we're going to do y equals -2 squared -4 times a -2 minus 10. And then we calculate it. Okay. We calculate it. So we're going to do, you always start with exponents first. -2 times -2. Okay. So that's going to give us, well, let me draw it. Let me just write it all out. Okay. Yes. So a negative times a negative is a positive. Oh, tell them. So you get a +4. But then we would drop down this negative that's already out there. Okay. Here you go. Here goes your passy. A negative times a negative is a +8. And then we would have a -10. So, what do you guys get when we simplify that? What do you guys get? Ugh. If you guys could see me now, you guys would be cracking up. Oh, no, Payday, I'm sorry. I am running out of space. Next time I only do 2 graphs on one. I thought it would be cool looking at all the different colors, but it's just too confusing. I know that for next time. Slide the paper over. Oh, sorry. There you go. Can you guys see it now? We're right here. So -4 plus 8 minus 10. -4 plus 8 gives us a +4. Minus 10 gets us a -6. Sorry, you guys. Sorry. So, yes, we would get a -6 here. So, then we will put in a -6. So, our vertex for this number 5 was -2, -6. Okay, so let's go plot this. Let me see. Let me use this color. So -2, -6 is right here. Now, is this graph going up or down? Tell me about it. Up or down? Put in the chat. Is it going up or is it going down? Oh, you can't see it? This one right here, I'm sorry, for number 5, is it going up or is it going down? So y equals negative x squared minus 4x minus 10. Okay, since it has a negative in front of the x squared, if you said it's going down, you are 100% correct. So go over 1, down 1, over 1, down 1, and then we would make our graph. And that right there is number 5. All right, you guys. My little guy has woken up, and I'm gonna have to call it a night. But thank you so much for hanging with me. I will be posting this on my YouTube page. So please, please go support me over there at Impact Math 19, okay? On YouTube. I'll post all my lives over there. Thank you so much. I found your live. This was so helpful. Oh, you're so welcome, Margie. I'm glad you are here for the ride. I know next time, less problems for one graph. I was trying to be lazy. Thank you, Payday. All right. Have a wonderful, blessed night, you guys. Bye.